This is a video for AQA Further Pure Mathematics. Vectors section 4.3, the perpendicular distance from a point to a plane. Well, this diagram illustrates the method we're going to use. So given a point and a plane, we want to find the shortest distance. Now the shortest distance is going to be a line from P which meets the plane at right angles. So the procedure is as follows. First of all, we set up an equation for the line which goes through P and is perpendicular to the plane. And we'll know that because in the equation of the plane we've got the normal vector to the plane. So once we've done that, we can then establish the position of the point of intersection, which in effect gives us this vector from P to that point, and then we can find the length of that vector. So we're going to work through this example then, where we've got the point which is -1, 3, -4, and the plane equation x plus y plus 2z equals 6. Now that immediately tells us that the normal to this plane is the vector 1, 1, 2. And so therefore that's the direction of the line that we want to have through P to meet the plane. So the equation of the line is r is equal to a known point, which is the point P, so -1, 3, -4, and then lambda times the direction vector 1, 1, 2. And that gives us the equation of this line. We want to know where does that line meet the plane, so we're trying to find out the coordinates of this point here. Well, to do that we can substitute the equation of the line into the plane. So we can say that the line equation and the plane equation must be equal to each other. So reading off, remember that r is just x, y, z. So we can see that x is -1 plus lambda. And if we substitute that into the equation of the plane, we get -1 plus lambda for x. And then y, we can see, is 3 plus lambda. And then z is -4 plus 2 lambda. So we've got 2 times that -4 plus 2 lambda. And that's got to be equal to 6. And if you rearrange that, you can quite easily see that lambda must be equal to 2. So now we know the value of lambda at this point of intersection, lambda equal to 2. Well, we know also the value of lambda at P, because this must be lambda equal to 0. So therefore this vector from P to the plane is twice the length of the normal vector. So the distance d must be equal to twice the length of the normal vector. So that's 2 multiplied by, then the normal vector is 1, 1, 2. So it's 1 squared plus 1 squared plus 2 squared. And that gives us 2 root 6. The alternative to that would be to substitute the value of lambda into r, and that would give a point here which is 1, 5, and 0. And then we could find the vector from P to that point. So 2 different ways there of working out the point at the base and the length of the line. So let's just check through that method again then. We said that the line through P which is perpendicular to the plane must be given by the vector for p plus lambda times the normal vector, and the normal vector we could get from the coefficients of the x, y and z in the plane. Then substituting those values of x, y and z into the equation of the plane produced lambda equal to 2. So p is at lambda equal to 0, this point here is at lambda equal to 2, and therefore we know that the vector is twice the normal vector, and hence its length 2 root 6. Well, that completes this video on perpendicular distance from a point to a plane, and also completes the section of videos on lines and planes.